Hi everyone, today I'll be explaining a few concepts on game hacking, and hopefully help beginners understand better what it actually means to make cheats. Imagine playing your favorite game, and suddenly, someone starts teleporting across the map, landing impossible headshots, or seeing through walls. It feels like they're breaking the rules of the game, right? Because they are. But have you ever wondered how they do it? What if I told you that the difference between a pro player and a cheater is sometimes just a few lines of code? So what exactly is game hacking? As I see it, it's the art of memory manipulation, altering the very fabric of a game's reality. At its core, game hacking is the practice of manipulating a game's code, memory, or network data to achieve effects not intended by the developers. This can range from simple cheats, like giving yourself infinite health in a single-player game, to more complex cheats, like aimbots or wall hacks, in competitive multiplayer titles. So, enough of that. Let's discuss on how it works exactly. All processes store memory inside your computer's RAM. You can assume that to be the case for now. I will explain in the future on why that's not always the case. Memory holding your health, position, ammo are hidden from your sight, but it's all inside the memory, meaning that we can read it. Now the question is, how? Fortunately for us, Windows provides us with functions on their Windows API to interact with other processes. I'm pretty sure you already heard about ReadProcessMemory and WriteProcessMemory functions, since they are the most common functions used on games with no kernel-mode anti-cheat. I will go more in depth now on why I mentioned kernel-mode anti-cheats. Usually, when you want to use memory manipulation APIs, such as WriteProcessMemory and ReadProcessMemory, you would need to acquire a handle to that process. You may ask me, what is a handle? You can think of a handle like a key to a house. When you call a function like OpenProcess, Windows gives you an access key to that process, of course, depending on the privilege you ask for. So what exactly are privileges? Think of it like a key that is limited to certain rooms in the house, meaning that you can only access certain specific areas. Now let's stop with the metaphors. What you need to do in order to read memory of another process is the following. First, you need to acquire a handle. That is usually done by the function call to OpenProcess. The second thing is, with that handle, you can call memory manipulation APIs like WriteProcessMemory and ReadProcessMemory. And that's all. Using that handle and the functions that I mentioned, you can basically read the memory of the process. So, if you know where a certain memory address is, you can literally just read it. Of course, if you don't know anything about low-level languages, you won't know what I'm talking about. So this video isn't made for you. If you wish for me to explain all those concepts, leave a comment on this video, and I'll further explain it on the future. However, as simple as they may seem, kernel-mode anti-cheats have developed ways to prevent you from accessing the memory. And how exactly do they do it, you may ask? Simple. The same way Windows have user mode APIs, they have kernel mode APIs. Functions like OB register callbacks allows drivers, in our case, kernel mode anti-cheats, to have a callback that will trigger every time a process tries to open a handle to another. You can already imagine on how they can prevent it based on what I mentioned. But basically, they check if the handle tried to be open has privileges to read and write process memory, and they simply disallow the handle to be created. That's one measure they take to prevent cheats from reading memory. What about the others? For example, they could hook functions like WriteProcessMemory and ReadProcessMemory and flag you or prevent you from accessing the game's memory. I mentioned a method called hooking or hooks that some of you cannot be so familiar with. So, what exactly are hooks? Think of hooks like ways to redirect normal code flow to your custom code. So let's say the normal functionality of WriteProcessMemory is as follows. Process A calls WriteProcessMemory. WriteProcessMemory then calls kernel to fulfill the request, and that's all. But that can be altered with hooks, and the code flow will be as follows. Process A calls WriteProcessMemory. WriteProcessMemory then calls an unknown function. The unknown function executes the unknown code and restores the control flow back to the original WriteProcessMemory. And WriteProcessMemory then calls kernel to fulfill the request. So you see the difference. Compared to the normal execution of the function, you can see that when a hook is installed, the control flow gets redirected to an unknown function. So in our case, it can be the kernel anti-cheat hooking WriteProcessMemory to, for example, return 0. So basically the kernel mode anti-cheat will prevent you from calling the original function. And that's basically hooks for you. So with all of that, you probably heard about the terms internal and external cheats. To put it this way, internal cheats are DLLs that are injected into the game's process, while external cheats use APIs like I mentioned to read and write process memory. However, most sophisticated externals do not use the Windows API at all. Of course, all of that is done to avoid anti-cheats. Eventually, you will have the following dilemma. What should I choose? External or internal? Internals give you full memory access to the game's context. So this means that everything the game has access to, you also do. You can call functions to perform tasks. You can abuse hooking to redirect functions to your own. A good example on a hook would be, let's say the game you're trying to make a cheat for has the function decrease ammunition. You could hook the decrease ammunition and make the game not decrease your ammo by simply hooking and not allowing the function to execute. Externals, however, do not have access to the game's context, meaning they are more limited. They can't perform hooks by design. They can only manipulate memory. Let's say, write to your character's position, increase ammunition, read positions, etc. So in the end, it always depends on how you perform your memory manipulations. For example, some may argue that being internal is easier to detect. They think that because, generally, for you to have a running cheat, you need to perform hooks on rendering functions like present from DXGI, and need to deal with memory allocations, executions, etc. From external, however, depending on a method to read and write memory, you can just execute your cheat on another process, making the anti-cheat not have access to the code you're executing. That is the case for most user mode anti-cheats. But when we are dealing with kernel mode anti-cheats, I can argue that being external, unless you have deep knowledge on memory manipulation, paging, etc., will usually lead to more issues, meaning they can detect you. So if you ask for my recommendation, if you want to go internal, do it against kernel mode anti-cheats. Prefer external only if the kernel mode anti-cheat is completely garbage or if the anti-cheat is user mode. For example, VAC from Valve. Let's talk about code injection. Basically the foundation of internal cheats. How does injection actually work? When performing code injection, you need to deal with 4 problems. The first problem, gain read-write access to the target process. Second, allocate memory, usually using virtual-lock function from kernel-32. Third, remote execution of code. And fourth, making all of that hidden against anti-cheats like Vanguard and Easy Anti-Cheat. So you may ask yourself, how do anti-cheats prevent it? Anti-cheats are known to hook functions like create remote thread, the most common function used to remotely execute code, which is needed to execute your DLL main. But most cheat developers are clever. They find ways to execute code remotely, without needing to call functions at all. This can be achieved by redirecting control flow from the game's functions. I'll give an example. Let's say you know the game has a function that's called every tick. Let's call it engine loop. If you write the code inside the function to perform the following task, move racks and your custom address, and then jump to racks, you can already see that by doing that, you would also gain remote execution without necessarily needing to call any functions. So that's basically it from me. If you enjoyed the content, please leave a comment and like the video. If you have any further ideas, or maybe you have some questions about certain topics we approached on this video, please also write a comment. I'll make sure to answer all of you.